welcome back to the channel. So today in this video lecture, continuing in this topological sorting series, we'll be solving this problem course schedule, and this problem uses the concept of topological sorting to find out its answer. So let's read the problem statement and let's see how we can solve that problem. I found this problem to be really nice, so please watch my previous video before you watch this video, because this problem uses the application of the concept which I explained in the previous video of the series. So basically you have, in this problem statement, you have to complete n courses. So you're basically some university student, and you have n courses which you have to complete. Now there are m requirements of the form course A has to be completed before course B. That means A is a prerequisite for course B. For instance, we must understand recursion before we understand dynamic programming. That kind of relationship. A has to be completed before B. We can't complete B before I complete A. Okay. Then your task is to find an order in which you can complete the courses. You have to complete all of the n courses, and these are the requirements, and there are m such requirements or prerequisites. Okay, now the task is simple. You just have to find the order in which you have to take the courses or complete the courses. So you will be given two integers in the input n and m, representing the number of courses and the requirements. Then all of these courses are numbered from 1 to n. After this there will be m lines. Each line contains a pair of integers a and b, where each pair of integers represent a directed edge which leads from A towards B. That is, course A has to be completed before course B. So in the output you have to print the order in which you can complete the courses, or if there are no solutions, in that case you have to print impossible. Fine. So let's see how we can solve this problem. Okay, so we have n courses. Let's take the example. Let's take this input test case, that is 5 3. So n is given to be 5. That means we have 5 courses. M is given to be 3. That means we have 3 requirements, and the requirements are something like this. 1 has to be completed before 2. Course number 1 has to be completed before course 2. Course 3 has to be completed before course 1, and course 4 has to be completed before course 5. Now there is observe that in this problem statement we require certain kind of ordering between the elements. We have 5 elements, and in this case the elements are courses, and there is a certain type of ordering. Okay, so whenever we have some kind of ordering between the elements, where we have to put some elements before while other elements after those elements, in that case think about the topological sorting. Think about the topological sorting. So we can see that course number 1 has to be completed before course number 2. So I can write an edge between these nodes like this, 1 and 2. So I can traverse node number 2 only if I traverse node number 1. I can traverse node number 1 only if I traverse node number 3, because I can move from 3 to 1 like this. Then I can complete 5 only if I complete 4. So this is the prerequisite for 5. 4 is the prerequisite for. Fine. So this is the given graph that we have now. Fine. So let's just see how we can solve this problem. We have some n vertices and n is 5 here. What we're gonna do is, now think about the ordering, the right ordering for this case. We can see that we can't complete 1 before I complete 3. So I have to complete 3. Then I can complete 1. Then I can complete 2. While 4 is not related to any of these courses, nor 5 is related to any of these courses. Now we can write 4 and 5 anywhere. I can write 4 and 5 and like this. Now 4 has to be completed before 5. That is the requirement. Now this is one of my answers. Okay. So this is one of the valid order. We can have multiple orders. Okay, 3 1 2 4 5. You can also write 3 1 3 4 1 3 4 1 5 2. This is also a valid order, because we can see that there is a edge between 3 and 2, 3 comes before 2. There is a edge between 4 and 5, 4 comes before 5. There is an edge between 1 and 2, 1 comes before 2. So we must satisfy the criteria for the topological sorting. And that's all. We can print any of these valid orderings. Now, that's all. That's pretty much the solution of this problem. Just take in the input n, take in the integer m, create an create a graph of n nodes, prepare the adjacency list by using these m edges that we are given here. Then from that adjacency list or graph, just run the topological sorting algorithm which we have explained in the previous videos, either DFS implementation or Kahn's algorithm implementation, and you will simply get the ordering. So let's just jump to the code implementation part. So this is just a topological sorting algorithm. We just have to print the top sort. So let's just implement the, so I will use depth first search implementation of the topological sorting. Let's write the function. So top sort, which takes in the number of edges, the adjacency list that we have. Okay, then what we have to do is just perform the BFS. Okay, so I hope you got the idea. We just have to perform the top sort. But imagine a scenario when we have something like, let's say the given graph is something like this. Like course number 1 is prerequisite for course number 2. Course number 2 is a prerequisite for course number 3. Now course number 3 is a prerequisite for course number 1. This type of situation. This type of situation is nothing but cycle. This is a cycle which we have discussed in the previous video, how to detect a cycle in a given directed graph. Now if there is this kind of situation, then we will never be able to complete the courses, because to complete one we require 1, then to complete 3 we require 2, then to complete 2 we require 1 again. So that's not possible. So we have to check if the given relations, if the given prerequisites, if the given graph has the cycle or not. If it has a cycle, then we won't be able to we won't be able to find the topological ordering for the given graph. Okay, so there is no way we can complete the courses. In that case, I will print impossible. I will just print impossible. Okay, so let's just code this solution. So we have this, I will be implementing the solution in C++. This is topsort function which takes in the number of nodes and the adjacency list. So it simply initializes a array visited which has a size of n, and then we will initialize a vector, then we will declare a vector which will store this top sort, and I will iterate over all the nodes of the graph, and if any node is unvisited, then I'm gonna call this function DFS for that node. Pass the adjacency list, the visited array, and the stack st. Okay, because we have to declare a stack as well, because we know that in DFS we store the top sort in reverse order when we are backtracking to our nodes. Finally, we iterate over the stack till the stack is not empty, and we're gonna push these elements top sort, and we're gonna pop these elements. Finally, we'll return this top sort array from the end of this function. So here we have our DFS function. So let's create this DFS function. This function takes in the node, the adjacency list, and the visited array, as well as stack. Okay, so here I will simply visit this node, then I will iterate over its neighbors, adg node. Then if this node is not visited, then that means I have to call this function. I have to call this function recursively for that node. So call this function for this neighbor, pass in the adjacency list, the visited array, the stack st. Okay. Finally, at the end, push this node into the stack. So this is the implementation for the top sort, for the DFS function that we use in this topper sort. Now let's see, before we check here, before we basically return this array, before we call this function in our main function, so let's create the main function which I require. That function is basically check course schedule function, the number of nodes, the number of connections, and the edges itself. Okay, fine. So let's call them edges. Now in this function, first of all, let's prepare the graph. Let's prepare the adjacency list. So let's declare an adjacency list. So since I will have to iterate from 1 till n, and here the visited array will be of size n plus 1. Similarly, here I have to, okay, and here I have m, and I will create a vector. Let's call it, I will create the adjacency list of size n plus 1. Okay, so iterate over all the edges and prepare our given graph. Now from the given graph, what I'm going to do is I'm going to return the, so from this given graph, what I'm going to do is I am going to, so first of all, here in this graph I will check if we have a cycle. Is a cycle, if there is a cycle in the given graph. So if there is a cycle, so let's pass in the given nodes, the adjacency list, and if there is a cycle, then that means we print impossible and we return right from here. Otherwise, I will return the vector which is returned by this function topper sort. Okay. Now, what is this is cycle function that we have explained in the previous video? So please do watch that video. Haven't watched my previous video. I explained these concepts in the previous video. That is how to check the cycle, how to detect the cycle. Fine. So this is that is cycle function. So that how we write this, how we wrote this function, this I have explained in the previous video. All I have to do is just initialize these visited and this stack recursion vector with n plus 1, because the nodes are numbered from 1 to n. Okay, fine. So this is a solution for this problem. So that's all for this video. If you like the video, then hit the like button, and if you have any comments or any suggestions or doubts, please make sure to post it in the comment section down below. And I hope to see you all in my next video. We'll be solving yet another problem on topological sorting.